Theorem 22. If two sides of a quadrilateral are equal and parallel, it is a parallelogram. New theorem here that's not necessarily a converse of what we've learned thus far, but this is what it's stating, that two sides are equal and parallel. Can't necessarily choose adjacent sides because you can't have parallel lines that are adjacent in a quadrilateral here. That'd be very difficult. And so obviously we choose opposite sides. We could either choose these opposite sides or these opposite sides. And whatever sides we choose, we're going to say that they are parallel and they're equal to each other. Because if two sides of a quadrilateral are equal and parallel, then this theorem is stating that this is a parallelogram. So I've stated that in the given already. I'm going to make my markings. I'm going to say that that is equal to that side, and I'm going to also, in my mind, I'm not going to put that kind of a marking on there. I'm going to, in my mind, know that those are parallel as well. Step number 2, I'm going to again draw an auxiliary line. Draw AC. So I'm going to draw my auxiliary line. There we go. And I'm going to label some angles here. I'm going to zoom in and label some angles. Angle 1, 2, 3, 4. And let me put my reason as well for being able to draw AC. I can draw AC because 2 points determine a straight line. Number 3. We've said this many times already. I hope we're starting to see there's a pattern in a lot of these theorems here. AC equals CA. ID. Number 4. We can say that angle 1 equals angle 2. We've stated that these lines are parallel. Alternate interior angles of parallel lines are equal. Alternate interior angles of parallel lines are equal. Number 5, we can now say triangle ABC is congruent to triangle CDA by side, angle, side. We stated that this is equal to itself, this is equal to that, and there we go. We have side, angle, side. Side, angle, side. There it is. Number 6, I can say that AD equals BC, and I said number 4 twice. Let's make that a 5. Number 6, I can say that those two sides are equal to each other because of CP, CTE. AD equals BC, and so I just said that AD right here is equal to BC, so I'm going to mark that as well with 3. And so look at that. We have in this quadrilateral opposite sides equal to each other. And so we can say that ABCD is a parallelogram because I'm going to say because opposite sides of a parallelogram are equal. Opposite sides of a parallelogram are equal. We could also make this a little longer and more rigorous if we wanted to. It wouldn't be that rigorous, really at all. But since these are congruent triangles, that means angle 3 and 4 are equal as well, which causes these to be parallel to each other because of alternate interior angles. And then this would be a more complete proof. This is a parallelogram because the opposite sides are parallel. We could easily do that. I believe this is sufficient for a basic proof, but if you wanted to go all the way to making the opposite sides parallel, You could easily do that in just 2 more steps, I believe. Theorem 22, if 2 sides of a quadrilateral are equal and parallel, it is a parallelogram.